And I'm back in my food, so you shouldn't hear my stomach. Okay. Determine the resultant vector F for a force vector of 1, 3, 1, 2, and it's 1 that is positive 40 degrees north of east added to a 1, 2, 6, 5, no, that's 19 degrees. Oh, north of west. So we want to be careful with our directions this time. And I'm going to fill our coordinates. Like that. And that. This time, we're not going to be using X and Y. It's going to be the direction after eat sour waffles. I just had waffles. Okay. The first force F1 is positive 48 degrees. If east is 0 and north is 90, positive 48 is going to be somewhere like this. Now, if you've been watching my vector videos, I think you can notice that I kind of have two ways of thinking about them. One where I say I have two forces, one going this way and one going this way. Sometimes I write both of them originating from the origin, but other times we have this force, and then after, if this is theta, I'll just continue on from the end point right here and make my line like that. Either way, the answer is going to be the same. It's just a difference in how you visualize the problem. Do it the way that makes sense to you. One benefit of doing it this way would be that it might be easier to see what the final force vector looks like. You can maybe make a good educated guess, maybe. This one, it's kind of harder because they're going in different directions, and then there's the angles. So this do what makes sense for you. This time I'm gonna do it so these both originate from the origin. But if you'd like to, you can write F2. I'm gonna start it from here. It's gonna go like that. But if you want to, you can write this line coming from here. Okay? Do what you like. So we have F1. This is F1, right? And it is 48 degrees north of east. So I hope that makes sense, like north of east or north of west. And F2 is there. We have an angle, 10 degrees north of west. If this said west of north, I don't know if the problem would actually say that, but it would be like this, and this would be our right? But that's not our problem. But just be careful, because I think there is a problem coming up where you have to be mindful of that. Anyway, we want to find our resultant vector f. How are we going to find f? Well, we're going to have a force. I don't know what it's going to look like. It's going to be a diagonal f, which will have an x component, fx, and a y component, fy. If we can figure out x and y, we can figure out f using Pythagorean theorem. So f squared, this is going to be our ultimate equation, right? F squared equals fx squared plus fy squared. This is going to be like our equation number 1. So let's find fx. fx. Fx is the sum of the x components, where it's going to be the x of f1, f1x, and the component of f2, f2x. We haven't found the arrows yet, so let's do that. The x component of f1, that's going to look like this, right? This is going to be f1x. The x component of f2 is going to look like this. And we have to be careful of the direction. It's not very obvious in this question compared to like normal xy coordinates, but I'm going to make up and write positive. So our f2x would be negative, right? Because it's going left, negative f2x. Let's try and find what these are trigonometrically. We have the hypotenuse f1. I'm looking at f1 right now. We have the hypotenuse f1 and we have the angle, and we want to find f1x. Can you see the c right here? That looks like a c, right? So we know it's cosine. So f1x, we can also write that as f1 cosine 48. Same thing with f2. We have f2, we have the angle, and can you see that's a c, just like reflected? So it's going to be f2, well, negative f2 cosine 19 degrees. Those are just our x components. So let me put that into our equation right here. f1x was f1 cos, that one's a little big. f1 cosine 48 plus negative f2 cosine 19 degrees. Let's put in f1 and f2. f1 was 1312, so 1312 cosine 48 plus, actually, I'm going to just get rid of that plus right here because the negative, so it'd be minus f2 was 1265. 1265 cosine 19 degrees. And now you want to calculate that, which should come out to be negative 318. It's always good to like try and do like a reality check if the number you seems realistic or not. And you know, some problems are easier to do that, while some are harder. So I don't know how I feel about negative 318 right now, but we'll just keep going. So we have f of x. So we got this, right? Now we want to look for f of y. F of y, same thing as the sum of the y components of each course. We have f1y and f2y. We haven't seen the arrows for that either, so let's do that. f1, the y component of this diagonal f1, that looks like this, right? This is going to be f1y. We can also express that using trigonometry, right? It's going to be this diagonal f1 and this opposite side. So can you see it'll look like a cursive S? So it's going to be sine f1 sine 48 degrees. And it's going to be positive because it's going up. Now let's get f2. It's the same thing. The vertical component is just this. And this is going to be f2y can express that trigonometrically with sine, like reflected. How would it be like this? It's this flipped. So like this. Well, anyway, you guys did this. So we can also call that F2 sine 19 degrees. And that is also positive because vertically it is going up. So let's put that into our equation. To get Fy, we are adding F1y was F1 sine 48 plus F2y was F2 sine 19 degrees. And F1 was 1312 sine 48 plus F2 was 1265 sine 19 degrees. Put that in your calculator all at once. Don't do them separately. Just do it at once. And am I making a mistake here? I don't think so. I think it should be 1386, I believe. Newtons. Comment if I get anything wrong. Okay. So now we have fx and fy, right? And now we're just going to put both of these into equation number 1. So we are looking for f. I don't like that it's square, so I'm going to take the square root of both sides. X squared plus fy squared on the root. Okay, fx was negative 318 squared plus fy was 1386 squared. Put that in your calculator and it should be 1422. So that is our final resultant vector. And do we need to find the angle? I'll just quickly do it. I don't know if it's even required. But so we have our triangle, we have f, we have f, y, fx. We want to find the angle of this. Let's actually, we want to be careful because remember, fx, we got a negative value. So if we were to draw our final resultant vector in our picture here, x, y's, we're going in a negative section. We're going this way. Oh, that's nice. We're going in a negative fx. And then we're going in a positive fx. Okay. So the resultant is positive, like this. And we want, nope, it's just f. And we want to find this. We can use sine, cosine, tangent, whatever. I don't think I've used cosine to find the angle yet. So I will do that here. So cosine. Wait, what did I just say? Did I say I was going to use sine? I'm going to use sine. So sine theta equals going to be that, right? So s flipped under Fy. We're looking for theta. Inverse sine F. Now we just put in our numbers. Fy was 1386. F was 1422. And I actually also need to put this in my calculator and see. It'd be good practice for you to do this like with cosine or tangent to see if we get the same answer I need to charge. Inverse sine fraction 1386 over 1422. That would be 77 degrees. Now, it's 77 degrees inside the triangle, but if we were asked what is in respect to the positive axis, you would have to consider this. I think it's hard to find out what you'd just do 180 minus 7, right? And that would give you this angle. Okay? And bye.